Hello everyone, and thank you for joining this webinar, Fighting DDoS at the Source, in collaboration between Capacity Media, Kentik, and Cogent Communications. My name is Saf Malik. I'm a senior reporter at Capacity Media, and I'll be hosting the webinar. I'd like to introduce Doug Madory, Director of Internet Analysis at Kentik, and Aaron Weintraub, Principal Engineer at Cogent Communications. During the first part of the webinar, Doug and Aaron will explain how organizations can identify customer networks sending the spoof traffic that leads to DDoS attacks. You will learn what spoof traffic is and how it contributes to attacks, how NetFlow analytics can police networks from spoof traffic, and finally, Doug will offer some advice for addressing customer networks sending spoofed traffic. We'll then have time for a 15-minute Q&A at the end, so please send questions throughout the webinar. There's no such thing as a stupid question. In the unlikely event that you experience any technical difficulties, please just refresh your window and this should correct it. I'll now hand over to Doug Madory from Kentik.
Great, thanks. Let me bring up our slide here. Yeah, so as Saf mentioned, my name is Doug Madory. I'm the Director of Internet Analysis at Kentik, and with me is my old friend, Aaron Weintraub, the Principal Engineer at Cogent Communications, and we're going to give you a talk today about using Kentik to fight DDoS at the source. So let's dive into it. So as you are likely familiar, the DDoS attacks continue to plague the internet. They happen many times every day of various types, and every few weeks we find a novel new way to do a DDoS attack. It is an ongoing problem that has affected, that affects just about every entity that has internet connectivity. One of the most common forms of DDoS attacks is a reflection attack. We'll talk about that in a minute. So this is a type of attack that takes the advantage of a stateless protocol by sending connections to many internet connected devices, and usually making use of like NTP or DNS, some kind of a UDP protocol that doesn't have a three-way handshake, and spoofing the source address as depicted in the diagram on the right, in order to make all those devices send traffic to the victim, which was the spoofed IP. So this type of attack takes place, like I said, many times every day. It is also one that there are some ways that we can try to fight it. Yeah, as you mentioned, this is a UDP protocol typically, although there are ways to use, people have come up with ways to do TCP, the types of reflection attacks. There is a lot of innovation in the space. In fact, it's led to this whole industry of DDoS for hire services, as well as DDoS mitigation vendors, and there is a lot of money involved because this is a common problem. And so how do we address this problem? And specifically, we're talking about reflection attacks. So there is, we can try to secure all those internet connected devices. If they weren't answering these types of UDP queries from the internet, then they wouldn't be able to be tricked into sending traffic onto a victim. Unfortunately, achieving some kind of security for all internet connected devices is unlikely anytime soon. We try to do our best there. There are some devices, sometimes like DNS servers, things that due to the nature of what they do, they have to answer queries from the internet. Not everything is like that. We could be a lot better in that space, but that's one area to attack this problem. The other is implementing BCP 38. So that's Best Common Practice 38. This is points to an RFC or a couple of RFCs that specify how to identify spoofed traffic so that networks can drop this again, so it's not the source of DDoS attacks. BCP specifies how one might determine if traffic is coming from a spoofed source, and by identifying the source address of the traffic as it comes in off an interface to a router. If that router would not have sent traffic back through that interface to that that customer network, if it was a customer network, if it because of the routes that it would forward to that interface, it would be determined that that is spoofed traffic. It's not a foolproof system. There are so there's a couple of issues there. Not all networks have implemented BCP38. Probably the biggest issue is just lack of awareness, lack of motivation. There are some corner cases where it does put some, it could potentially put some traffic at risk of you blocking legitimate traffic in the event that there's some sort of asymmetric routing going on between two transit providers. But I would guess if maybe there's a study, but most the lack of BCP38 is just simply so people just haven't done it. So this is an issue we've got. We can't secure all the UDP servers, internet connected devices of the world anytime soon. We've still got a lot of networks that still haven't implemented BCP38, so they are sending spoof traffic. And so Cogent, given that it is one of the largest backbone carriers of the internet, is in a unique place to both be have the opportunity to well, a lot of this traffic has to cross its network, so it's in a great position to identify and try to remediate some of it, certainly within its customer cone traffic that's spoofed. So that's what we're going to talk about today. That's why Aaron's on this webinar. And a great way to get at this is to look at NetFlow, and using Kentik, which is known for its NetFlow analytics. We look at Kentik's Data Explorer. We can identify spoof traffic fairly easily and allow a customer to, allow a user of Kentik to identify spoof traffic and remediate that with their customer. So I'll hand it off in a minute here to Aaron, but just the methodology boils down to 2 steps, and we're going to walk through some screenshots of Aaron's workflow, or he's going to take you through that. But basically, there's 2 steps. You have step 1, where you're just trying to find spikes of packets from customer networks that are going to a large set of unique destination IP addresses using commonly abused UDP ports. That's a pretty good first indicator that you've got someone who's launching DDoS attacks off of out of your network or your customer's network. That alone doesn't. There are possible benign explanations for that kind of scenario. But then step 2 is then when you drill into those candidates, you figure out what are the source IPs and what are the source ASs, autonomous systems for those IPs. They typically jump out at you that this is an impossible distribution coming from the customer. But let me, with that, let me pass that over to Aaron and let him take you through how he uses Kentik.
Great, thanks, Doug. So as Doug said, with being working at Cogent Communications, we do see an enormous amount of the traffic on the internet, and we have a really great view into some of the sources of these traffic. I've been in this industry for over 20 years, and being with my position at the company, I have an actual ability to do something about this. So the first thing we're going to do is we're going to go into the Kentik Data Explorer, which is available from the main menu, to set up the initial view of how we're going to find these potential customer attack sources. What we're going to do is we're going to set up some filters. First of all, we're going to look at only traffic coming into the network from an external source, right? We're not going to look at backbone links or anything else like that, just external sources. In our case, we're also going to exclude private peers because the purpose of this workflow is to find customers, not peers. We're also going to filter it to only look at packets going to certain commonly abused reflection ports, which in this case is UDP, and you can see here there's a list of them. We can provide that in some form later. It's going to be DNS port 53, connectionless LDAP on 389, Memcached on 11211, and several other ones that have been identified as being prime amplification or reflection services. Next thing that's important is the metrics, because you usually, as an operator, want to look at the bits per second. Well, the whole thing about why reflection attacks are so bad is because they can start with an enormously small number of bits per second, but a large number of packets per second. So in this case, the packets per second is the important thing to look at. In addition, we also want to look at the unique number of destination IPs, which is a metric that Kentik can generate for you, which basically allows you to see to how many different destination IPs was this flow talking to, because that is a really good indicator of one of these attacks in progress. And lastly, the group by, you're going to want to group by provider or interface, depending on if you've done the necessary workflow to set up provider dimension in your environment, almost the same. And then the device, because you want to know from what device the customer is on, right? So that's the three things we've got there: the filters, the metrics, and the group by. And then you can run that, and you get what I like to call the first view, or we have this as a save view of the amplification initiation finder, right? We have the source provider or customer name, the device, and then the two metrics columns, which are important: the unique destination IPs and the packets per second. And you want to actually look at this view sorted by both those metrics, because they will have different things appear and show up of interest, right? In this case, we've done an initial sort by the max number of unique destination IPs. And you can see here that some of these are quite large in terms of the number of IPs that they're talking to, and also the number of packets per second that are being sent. And you can see here that the blue one, I think it's customer B, has a really huge spike from almost 0 to over 3 million packets per second. And those are going to over 2,000 unique destination IPs, which is a very good sign of a initiation of a reflection attack. Again, the same view, but now looking at the packets per second sort. So it's a little different view. It's most of the same information, but both of them are good hallmarks or good signs of this kind of attack. So once you've identified one that you want to look at some more, then I go to my second tab, which I usually have open. So this tab is going to be filtered on. So the filtering options will be, first of all, the unique customer that we found from the first view, right? So the customer name. And again, we want to look at the same UDP ports we looked at from before, because we don't want to see any other extraneous ones that would throw us off the track of what this customer is doing. In this case, instead of grouping by device, because we already are going to be looking at one device, right? We want to look at just the source IP address. We also want to look at the source AS number, and then we also want to pull out actually what that destination service protocol is, whether it was DNS, LDAP, Memcached, or something else. And in this case, now we actually can see what the actual source IPs and source AS numbers of the traffic was, along with the destination port. In this case, you see it's SNMP, domain, WS discovery, and these are all very commonly abused amplification and reflection ports. And the key here you're going to look for is that, do these IPs make sense for this customer port in this location? You can see here, for example, I think this particular customer I was investigating was a web hosting provider somewhere in, I think, Georgia, right? But you can see here the source AS numbers that it pulled up with was Microsoft, was Verizon, was OVH Cloud, which is a big cloud provider, right? I would not expect to see any of these source IPs coming from this customer. So these are, by definition then, must be the victims of this kind of attack that's being initiated by this customer. So this is when now your organization has to figure out how to move forward with this information. So first of all, we could simply send the report to our abuse team and have them initiate contact with the customer, take action, and so on and so forth. But it might not actually solve the problem, because if we just turn off the customer or suspend the customer, right, we haven't made any progress in the actual stopping this problem, because maybe then the customer might not know that this attack is happening, and then the bad actor would go someplace else and come back. We just don't know. So what I feel I can do, given my position in the industry, is to actually help them stop this problem so their network can't be used anymore as a source for this kind of traffic, right? And whether that's, as Doug discussed, the BCP38 or other things, to get them to understand why this traffic is so harmful for the internet and what they can do about it. But we have, because of the size of our network, we have many, 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 many customers all around the world, and we have a lot of problems sometimes with this communication, right? First of all, it's simply language, right? I talk English. I know some other languages. I know a little bit of Spanish, but my technical Spanish is certainly not good enough to explain this kind of situation. And we get other of our customers from all around the world who simply may not understand what we're saying in terms that they can use for themselves, actually use as actual information themselves. It could be someone who is, doing too much with too little time, right? Just one network engineer for a giant company, or they may not know what I'm trying to tell them, right? This does take a little bit of explanation for someone who's never seen this common problem before of what this might mean and what this means to them. What can they do about it? And then unfortunately, for some reasons, there are also some network teams that simply don't see this as a priority because it's not impacting them. And by and large, that's not wrong, right? This customer that I had shown you before in the slides, these attacks were not against them. These were against other people on the internet, but they were part of the problem because that is on their network is where the attacks started. And so they may not see it as something they want to devote time to resolve it. And then there's also a variety of other reasons, and myself and several other people have been sharing information about some of these customers, and we have basically put together a bingo card, if you will, basically kind of showing the gamut of responses that we've gotten from different customers, from myself and other providers who have reached out in a very similar fashion to these customers with some explanation, with some with the Kentik report, which can be shared. And this is the responses we get, right? We've gotten responses from some government entities that, or educational entities that, well, due to privacy reasons, they don't collect NetFlow. That's not a great response because the attack is still coming, right? This is something you need to resolve. Or someone, okay, we blocked those UDP ports. Well, again, that's not really a good solution to the problem because, for example, the domain port is used all the time, right? So there's just a variety of different responses we get. So it's sometimes a very continuous back and forth with the customer about explaining, no, this is the problem, this is how it works, and so on and so forth. And then I think that's all for basically my explaining the Kentik workflow, and I'll give it back to Doug, where he can kind of give you some more statistics and information about these attacks as a whole.
Thanks, Aaron. That was great. Yeah, so just to wrap up some of this discussion, and we'll jump into some of the questions that have been coming in. I wrote this discussion we published it as a blog post maybe last month, a few weeks ago, and we cited a webinar that I did with Matthias Friedstrom of Aurelion, where he came on, and from their perspective, is another global backbone carrier who we have a great relationship with, and they provided some stats on DDoS attacks, and they saw some of this trending downward, and it gives hope that some of this effort, what Aaron described, it's efforts like that. There's a lot of coordination going on in the industry these days between the tier 1 operators, including Cogent, Aurelion, several others, major internet firms, Google, Amazon, those kind of folks, of the experts coordinating and trying to identify and trading notes. And I think we've made some progress. There's also separately, although there's some overlap, this big pipes effort, again, to go after, identify using working with U.S. law enforcement to identify who are the DDoS for hire services and try to take out those. So usually criminal operations. So there's been a lot of pushback of fighting DDoS, and we've made some progress for the first time, maybe ever. And if you run a network, you could be a part of this too by doing this kind of stuff. Yeah, the key insight there was, this isn't infinite, the number of networks that are launching these attacks. There's a finite number, and it's small enough that, if people collected their intelligence, we could probably identify the worst actors and try to mow the lawn a little bit, take some of these guys out. Yeah, so that's a positive thing. And, I think maybe we'll leave with a call to action. If you operate a network and you're allowing spoof traffic, chances are you are facilitating DDoS attacks against other companies, and you have, we would argue, a moral responsibility, maybe not legal, but you've got at least a moral responsibility to try to investigate and eliminate that DDoS traffic. And if you have somebody like Aaron or an expert from one of the other backbone providers or one of the cloud providers reach out to you that's saying that they're detecting spoof traffic coming from your network, you're going to need new tools to investigate those claims, and you're not going to want to be, completing Aaron's anti-spoofing response bingo card. You want to have a good response ability to identify what the problem is on your own and remediate that, because this is the internet is a collective effort. We have to work together on a problem like this. So with that, why don't we take any questions? Let's see. Saf, do you have any?
Yeah, there's a couple that have come in. I will start off with this one here. Doug, what other action can people take to address this problem?
Yeah, Aaron, do you want to take that?
Yeah, sure. So, as I said before, and as we indicated, right, this kind of attack starts in someone's network, and is generally, the victims are generally other people, right? So basically, what I'm asking the audience listening or to do is become informed about this, right? Make yourself part of the solution, not part of the problem, right? Especially if you have contacts in other industries, other countries, that are in the internet sphere, right? Reach out to them, get them interested, get them information about these kind of attacks, because that's the biggest problem that we have is outreach into some of these countries and communities, which are harder for me to get into. And right, if I'm coming to you and you're my customer, I'm the provider, right? It's a different relationship, right? And they may not believe what I want to say, or you just want money or whatever, right? But I'm trying to tell them about a real problem. So I think sometimes if they have someone else that they maybe trust, maybe it's some kind of a network operators group in a different country or something like that can reach out to them and spread the word about these kind of problems that exist, I think that goes a long way towards making the mission I've taken on easier to basically at some point have this threat almost completely disappear from the internet.
Cool. Let's go to the next one. If someone is a victim of a reflection attack, what can they do about it?
So I guess I'll take this one as well. So if you're the victim of a reflection attack, right? So there's two things that you can do in general. One thing is, what can I do right now to stop the attack or stop the impact on my network? And that is really the same thing as any kind of attack you're under, whether it's many solutions, black holing, something like that. But if it looks like you're the victim of a reflection attack, which in this case would be, thousands of IPs coming at you, and they all have a source port of one of these abuse services, right? LDAP, DNS, and so on and so forth. You can go to your provider and say, hey, I think I'm the victim of a reflection attack. Can you help me please trace this back to the source, right? And I would hope at some point that there would be sufficient expertise at that provider to assist you in that goal, right? And then basically they would talk to their provider and so on and so forth. And eventually it would get its way up to the people who can see where the attack's actually coming from. Oh, this is coming from a hosting provider in Czechoslovakia. Oh, this is coming from some, WISP in Omaha or whatever. And then they can apply that same pressure or that same discussion that I have with my customers about getting the problem resolved. So 2 parts. One, it's just a normal attack from your perspective, a lot of traffic. But because it's a reflection attack, there is a source that can be found, but you as an edge node would have to enlist your provider to initiate that traceback process.
And this one from Barry Green, Akamai Technologies. Much of this work requires NetFlow in the network. Many think it is expensive. Can operators and enterprises deploy open source NetFlow than those pulled into Kentik?
I guess I'll answer this. I don't know of a way to do that presently. It's something maybe we can look at and consider. If we look at just Aaron's workflow there of just the idea, just this one set of functionality to identify spoof traffic. I don't know if we could offer that as a service that someone could import NetFlow specifically around that, but I don't have a good answer for that. It's a good question, and it's something I'll take back to our product management and see if there's something for the good of the internet. Could this functionality be provided more widely?
And as an add-on to that, there is definitely a cost to deploying any kind of NetFlow analysis, Kentik or anything else, and that's true. I honestly feel that today in 2023, it is almost getting to be a requirement of a good operator to have a NetFlow analysis package, right? Back in 1995, 1997, you could just use RRD tool and you're done. And I feel that's really inadequate these days to be a good commercial operator, a good internet citizen.
Another question, would this address the newly discovered HTTP 2 rapid reset attack?
Aaron, you want to take that?
Sure. So I looked at that. I'm aware of it. I should say I'm aware of it. And no, this wouldn't have anything to do with that. That is more of a what's called like a layer 7 attack, where there's actually attempting to starve a server of resources, whereas these kinds of attacks that are being discussed here are more just a flooding attack to overwhelm a link, right? Trying to stuff 15 gig down a 10 gig pipe, for example. So it would not do anything against that kind of attack.
One from Tarek Sendi from Team Simru. Based on NetFlow data, how can you can differentiate between normal DNS traffic and DNS amplification DDoS attacks? How can you? He said. Sorry.
That's fine. So that's a very good question. And so one is I want to make sure that we state the question correctly. I think you're trying to between normal DNS traffic and being the source of one of these attacks, right? So basically, it is not obvious, right? It really depends on your the traffic profile of your customers. Basically, adding in that unique destination IPs metric really does a great job of cutting down that kind of noise, because again, you're looking for an unusual traffic pattern, right? So if you see a particular customer of yours all of a sudden shoot up to sending traffic to 2,000 DNS servers and then goes down to none, then it is really a sign of the attack. So using that unique destination IPs metric along with the packets per second is a pretty good vantage point pretty good distinguisher between normal traffic and a DNS attack or a DNS amplification attack. And then also looking at those source IPs in that second view and realizing that, hey, this is a hosting customer in Georgia. I shouldn't be seeing source IPs of hosting providers in Europe from them.
Aaron, another one for you from Barry, Akamai Technologies. He said, should you ask your upstream ISP about their NetFlow deployment? And are you at risk if they do not run NetFlow and cannot track DDoS?
So I think it's a great plan for any customer to ask their upstream ISP what their capabilities are. I would say it's two parts to that, right? So one is stopping the attack, right? And stopping the attack these days, there's a multitude of vendors which would allow real-time black holing or scrubbing or cleaning, right? And that's all there. What we're talking about here is a slightly more narrow focus of making sure that you as an ISP, as an operator, are a good internet citizen in that you are taking an active role into finding and stopping the sources of these attacks so that they can't happen anymore. So certainly I think that is a good plus in your ISP's favor if they are if they do run NetFlow and they can track these kinds of things, but that's a different thing than stopping an attack towards you as the customer.
One more question from Jeremy Trass. He says, will this presentation be available to attendees after the session? I do believe that is the case, Jeremy. And another one from Tarek. Why most ISPs don't apply BCP 38? And can we apply BCP 38 on T1 or T2?
So the answer to that is going to be because it's not meant to be used there, right? So BCP 38, also known as anti-spoofing, on a router is a configuration knob you can turn on that basically verifies when traffic comes into the router on this particular interface, that the best route for those source IPs is back out that interface. So for example, this only works really well, or only is 100% effective against statically routed customers or very much end users. So it needs to be applied at the edge, where there's no possibility of asymmetric routing. As a tier 1 or tier 2, if you apply this on your huge downstream customers, right, your multinational ISPs that buy transit themselves from several other ISPs and have many other downstream customers, you run a high risk of inadvertently blackholing the traffic that's coming from them, because the best route to them may be through their other ISP. So while certainly an ISP like myself could turn on the BCP 38 feature towards a customer, a large multinational customer, it would have a high possibility of blackholing traffic. So we don't do that. Instead, we do basically what I have been talking about in the first half of this presentation or webinar, which is to reach out to that customer and say, hey, this traffic looks like a problem. You need to find the source of that traffic in your network and basically have that same conversation. Say, hey, here's this traffic. Can you please track it down? And they could do that with the report I provide them using the Kentik Share report, which has all the information and the times that they need to, the UTC times of the actual attack, so they can go back in their tooling and find out where the attack is coming from.
One more question, Barry, from Barry. One of the tools used by the community is Shadow Service Free Cyber Civil Defense Reporting. It will list out the devices in your network used by DDoS. They also have reports on the potential DDoS reflectors. Can Kentik pull in Shadow Server's API to us, that list of IPs to track?
Let's see. We pull in a lot of security-related data to enrich our the NetFlow. I don't know if this is on our list, but if it's not, we can take that back and make sure that gets added to it. And so then, yeah, you would be able to quickly. It would add a bit of add to the process Aaron mentioned if you had another indicator to use, that these are potential reflection points. But it's a good suggestion, and I'll take that back again to the product management. I think there's a way to do that.
Yeah, I don't think we have any more questions.
I see one more at the top. I think.
Will the UDP port list be available to attendees after the session?
Yeah. So I saw that. I was thinking maybe the way to do that, Aaron, maybe if you want to give me your list, we can just add it. We can update the blog post that this is based off of, and just put that. We can put that on the blog post so that if people can see what the list is. Just to, I think it's probably not that controversial, but why don't we put it there? I'll after this call get the list from Aaron and update that, and you can find it there. Looks like we've got maybe one more question.
Yeah, one more. Michael Fiumano, Cogent Communications. Hope I said that right. He says, what about using RPF loose mode instead? At least you would protect yourself against spoofed RFC 1918 source addresses, right? Is that better than nothing?
So certainly, as an ISP, right, turning on RPF loose mode towards your customers is a good thing, right? Because basically it means that when you get those packets in, RPF loose mode means that if your router has no route back to that source address, it would then drop the packet, right? And if you think about the internet, right, if you as an ISP get a packet for which you have no way to return traffic to that source IP address, more than likely it's garbage traffic. Right now, obviously, it couldn't then be actually used for a reflection attack because the real source IP isn't on the internet, right? It's an RFC 1918, it's a Class E, it's reserved, it's whatever. So at the very least, it would definitely stop you from getting in junk traffic that you could do nothing with. But as far as stopping an ISP from being a intermediary or someone who is allowing this attack to happen, it wouldn't stop that because by definition, this attack is going against a real IP out on the internet.
We got one more comment from Barry. Barry's kind of the third presenter on this presentation. I really appreciate it. No, it's great stuff. So Barry writes in to answer the two questions ago about publishing the list of UDP ports. I'll add that to the blog post, but Barry's suggestion is if you search for exploitable port filtering, there's a guide that's been created that discusses this and provides some guidance and lists of ports that you can track.
Right. So and it's certainly right. It's a good idea. There's many ports out there that are exploitable. However, I would be very, very, very cautious about filtering these because the problem with filtering on the internet, and again, Barry and I and many other people have been on the internet a long time. The problem is once filters get in, they're very hard to get out. People put them somewhere and forget about them. People leave companies and so on and so forth. So although there are certainly ports that are, I want to say bad, that are exploitable, right? Sometimes like DNS, right? We all need DNS to function, right? We all need other protocols to function. So for purposes of, again, this, I won't say very narrow, but this singular use case of finding this traffic at the edge, certainly knowing those ports is good. Have them in your tools to help you find lots of traffic to those ports is good, but filtering them is something I would really advise not doing, only because there's many legitimate uses for those ports. The only illegitimate usage comes in the fact of spoofed source traffic, which applying the anti-spoofing or BCP38 filters at your edge would stop that traffic from ingressing your network.
So Aaron, in your workflow, the way you're using that port list is just for identifying candidate traffic that could indicate spoof traffic, right?
That's correct. I'm just basically, these are, and I think you maybe touched on it briefly, but the thing that makes these ports and services so attractive for amplification attacks is that they are UDP, right? One way, just send a packet out. And also there's a very large amplification factor, right? In that you send a small packet, maybe 10, 15, 20 bytes, right? But you get a packet back that's maybe 1,000 bytes. So a 50 times factor. And there are some protocols that have really, really, really big amplification factors based on how they were initially outlined and designed by the IETF and so on and so forth, which have then been adapted over the years to be a little less destructive in their initial configuration.
We have one.
Saf, I don't know. It looks like there's maybe one last one. There's been a lot of questions. This has been a great discussion, though. This is phenomenal, and thanks Barry a lot for your comments.
Yeah, this is great engagement. Thank you for the questions, guys. We'll just take this last one. It's about QUIC network protocol. Does this make detection of amplification DDoS attacks more difficult?
Do you know this one, Aaron? I'm not familiar with.
I unfortunately do not know what fake network protocol is. I'll have to do some research, and maybe if I find out, and you can amend your blog post. But unfortunately, I'm not familiar with the QUIC network protocol.
All right.
Tarek, sorry about that. But yeah, that's all we have time for. Don't forget to check out the attachments below this webinar, which include case studies, a white paper, and even a Halloween story by Kentik. Thank you to Aaron and Doug for joining us and providing some great insights. And thank you to everyone for watching. We hope this has been useful. Please don't hesitate to reach out to Doug and Aaron for more information. Thanks, guys, and thanks a lot for joining.
Yeah, thanks. Thanks for the questions.
Thank you very much. Welcome.